What's up, everybody? Welcome to another episode of Let's Ask Paul, the podcast where I, Paul Abernathy, do my best to answer your electrical code related questions submitted through our online portal at paulabernathy.com. So before we get into today's episode, I do have people that ask me, well, Paul, what makes you qualified to answer people's code questions over people that just posted on social media? What makes you so special? Well, first of all, nothing makes me special. I feel happy. Oh, so happy. Or maybe that's supposed to be I'm so special. Anyway, that isn't. All I can tell you is that I have been doing this for 34 years. I am the founder and CEO of Electrical Code Academy. I also created and trademarked the Certified Master Electrical Code Professional Program that has certified professionals all over the country. I've served for NEMA. I worked for National Electrical Manufacturers Association as their NEC code expert in field rep for the southern sections, about 13 or 14 states. I've worked as an engineer for the city of Richmond, Virginia, overseeing inspections and plan review in the engineering department. I have worked for the city of Alexandria, Virginia. I was the head of the code inspectors and the education on the NEC. Was an electrical contractor for many years, 20 plus years. I tried to juggle all that and tried to keep everything going for years. And again, I am director of technical services for a major manufacturer of wiring cable. So I've held all of my ICC inspection certifications from residential to commercial to plan review. I'm a master electrician in multiple states. I could go on and on and on. I've written books on the NEC. I co-wrote books with Phil Simmons and for Cengage. Let's see, what else? My first book was written in 2007, which was purely for electrical inspectors and home inspectors. I don't know. I've over 1,000 episodes and podcasts. I'm all over social media, so my opinions are out there. So I'm not this random guy that just puts them out there on a message board and doesn't do anything. Oh, I should also mention that I serve on Code Making Panel 5 and Code Panel 17 for the development of the National Electrical Code. And I have for many cycles. So I'm just not, I'm not special. Again, I'm not. But I have been around a little bit. Okay. And it's not to say that I can't be wrong, but I am going to probably rely on my interpretation over somebody that just randomly shows up on TikTok or Instagram or Facebook groups or whatever and wants to beat their chest to seem intelligent. I don't need to get into those arguments. You can look who I am. Just open your code book up. I'm in the front. It's not a big deal. Okay. All right. Look, why did I tell you all that? I told you all that to be able to establish the fact that I'm just not your regular Joe Schmo that comes on here. I don't just write books and have never served on a committee. I've served on UL committees, ASTM committees, NEMA committees. I have 9 patents to my name in the wire and cable industry. I've got tons of federal trademarks and service marks. So again, when I tell you somebody gives you questions and answers things for you, and this is why it's so important to tell you about the free service at paulabernathy.com. I'm here for you. I'm here to answer questions for you, okay? The next generation of young folks is going to have to pick up that tab because a lot of us older folks are going to be cashing in, baby. We're getting old. We ain't going to be here long, okay? The Paul Abernathys, the Mike Holtz, the Ryan Jacksons of the world, they're going to go away. The Phil Simmons, the Charles Millers, we're getting old, okay? And I know, people don't want to hear that, but it is what it is. And so eventually we're going to check out to the big, whatever the electrician's retirement home in the sky or something at some point. So we need to make sure that people are passing on knowledgeable information, accurate information, and stop this social media people that just post stuff and they have literally no clue. And they don't back it up with code. They don't give any code references. They want you to believe them, but they don't back it up with anything. Okay. enough of that ranting. I held you in here for 5 minutes ranting. So now let's get into today's topic. So I was asked the question, and this is going to be maybe difficult for me to convey over a podcast. I have videos on this over on our Fast Tracks Tube platform. We'd love to have you over there. It's a 50% off right now if you use the coupon code 50OFF. All caps, by the way, 50OFF, and that'll get you 50% off your annual membership. We have an 8-hour calculations video over there. I have I think it's a 12 or 13-hour grounding and bonding video. We have an 8-part series on swimming pools, spas, and all that I did with Vince Delacroce. Great guy, by the way. So that is all part of that annual subscription to Fast Tracks Tube. So give it a consideration. We prefer you to, if you're going to say thank you for what we do, I prefer you to get into that because you get something for it. You get videos. Beautiful thing, right? Okay. All right, let's get into today's episode. So I've been asked by somebody to explain how to calculate for a new restaurant. In their case, it was an all-electric restaurant, and how to calculate the size of the service. Okay, which is also going to apply to a feeder, right? Because you could have the main service outside and then it changes over into a feeder to come into the building. Okay, same concept. But they want to know, how do we calculate that? Now, typically, I would calculate that using part 3, which is a standard method and allows me to go through and collect all my things together, right? And just size it that way. But that would be an excessively large service, because I'm not going to have that much demands that I can apply. I mean, obviously I will for the receptacles at 180 VA. I will get a break on that when you have a certain amount. I will get some allowances, right? I will get some allowances for non-dwelling type of appliances. Okay, I will get some breaks for that. But for the most part, I'm going to use something that is found in the optional method. And just to let you know, for electrical exams, the high probability is when they ask you about a restaurant calculation, they're not going to throw all these things at you because you don't have enough time. But what they'll throw with you is a total VA count that maybe have done by the engineer, because typically restaurants going to be designed by an engineering firm, right? They're going to, whether it's a chain restaurant, they're going to have these designs. They're going to be very specific about what they want, because this is typically not a one-off. They know what they're doing. The design engineers know what they're doing. So they're probably going to give you a set VA value, volt amperes value, okay? And you're going to need to know, okay? And they may even give you all the load anyway, and all you got to do is just follow directions. On an exam, typically, and I can tell you this is the case in the Texas exam, what they try to do here is just give you a total connected load, okay? Everything that's been connected. So you haven't applied any demands yet. It's just everything just added up. What is it? It's all the electric loads. That's the heating and cooling. That is the every load that is connected together, okay? So all electric loads, just add it all up at its face value, okay? And then you're able to then go to 220.88 and you get to use the optional method. Now, it'll tell you right in the beginning of 220.88, it'll say that you can use this 220.88 in lieu of part 3. What that means is it's okay to use this table, use this optional method, but if you wanted to use part 3, you could do it if you wanted, okay? So we're going to be looking at what you're likely to get on an exam, and that is the application of the optional method under 220.88, okay? All right, so what you'll see here is I'll read 220.88, and then we'll give you an example. It says calculations of a service or feeder load where the feeder serves the total load. Again, it gave you that example, whereas you may have the main disconnect outside, and then it turns over into a feeder coming in and hitting the gear stuff inside. That's an example where that feeder is going to see the entire load of the restaurant. It's just simply allowing you to put the equipment further into the building rather than outside or nearest point of entry. You get me? So you might have the main disconnect outside, could be rather large, 1200 amp, whatever, and then it changes over and you've got feeders coming into the building, okay? All right, so where that feeder serves the total load for a new restaurant shall be permitted in accordance with table 220.88 in lieu of part 3 of this article. Okay, so I don't have to do the piecemeal approach in part 3. I can just simply take up all of the electrical loads, and that includes both the heating and cooling, in order to come up with what we call the total connected load. And a lot of the engineers will do that. They'll just simply take all the loads that are in question, right? Now, it goes on to say the overload protection of the service conductors shall be in accordance with 230.90 and 240.4. Well, of course, 230.90 is saying each ungrounded service conductor shall have overload protection. So again, you got to have the overload protection. You got to protect your conductors. And so it just should be a given. And then of course it's reference to 240.4 is just again reminding that you're going to protection of the conductors. And then you'll have, all these different allowances, like where you have overcurrent devices rated 800 amperes or less, and then the next size up allowances. And then of course it'll remind you that you have a situation where you have over 800 amps and you have overcurrent protection. And so you have all these rules that you have to meet. Okay, that's all it's reminding you is remember you're going to meet all the general rules. It says feeder conductors shall not be required to be a greater ampacity than the service conductors. So that makes sense. If these feeders are coming from the service outside and the service conductors were calculated to be a certain size, well, there's no reason for those feeders inside that are meeting this allowance. Again, remember that it has to what? Serve the total load. Then this is just saying that in no case does those feeder conductors have to be larger than the service conductors. Okay? So you don't have some weird situation where these feeders end up calculating larger than what the service conductors would be. Okay? So the feeders, again, not required to be a greater ampacity than the service conductors. Makes sense. And then lastly, it says service or feeder conductors whose calculated load is determined by this optional calculation that we're getting ready to do. It says shall be permitted to have the neutral load determined by 220.61, right? And 220.61, for those that do know, that actually is in the that's in the standard method, right? So again, it's going to be one of those things that you're going to have to do a calculation, and it sends you back to the 220.61, okay? But notice that it says that the service or feeder calculations whose calculated load is determined by this optional method shall be permitted to have a neutral load determined by 220.61. There are some applications where the engineering and design is going to make it full size, same as whatever these ungrounded conductors would be. But you are permitted to use the allowances in 220.61. Just remember that 220.61 is under part 3. So that means that where you saw that it said in lieu of part 3, well, in order to calculate for the neutral, then you're going to have to go back through and calculate that neutral, which is you're trying to determine the maximum unbalanced load. And since 220.61 sits in part 3, it's not in part 4. It's in part 3. That's going to force you to understand that you're going to have to do what? You're going to have to be able to do a standard calculation. So if anybody ever tells you that you don't have to worry about how to do standard calcs in part 3, we call it standard, but it's just part 3 method, don't listen to them. You need to know how to, even though your question might be on the optional method, you need to understand how to do the regular method under part 3. Now, good news for most electrical exams, when they give you a total connected load, they don't give you all of the variables in order to be able to calculate the size of a neutral load. So that means you don't have to consider it. You're only sizing, maybe it wants to know what the size of the service. It's not asking you for the neutral, okay? So again, that makes it easy for that. But in the real world, just remember that you can use this optional method, but when it comes to the neutral, you can use the 220.61, which is under part 3, which means you're going to have to do a standardized calculation. But that is permitted. It says it shall be permitted. If you want it to be full size neutrals based on the size of your ungrounded conductors that you're going to do in this optional calc, you can do that if you want. And it's just going to be bigger neutral conductors, but that's never going to hurt anything, okay? All right, hopefully I'm clear with that. All right, so let's look at an example. So let's say, in our example, let's say that an engineer gives me, or the exam says that you have 600 kVA of total connected load. And they're giving me that. They're telling me, okay, we'd added everything up. We've already done all this. We added all the AC and the heat. We took all the electric loads. We added everything up, and it is 600 kVA. And that's what it gives you on the question. So now you're saying, okay, how the crap do I apply this table for that? Okay, well, let's look at the table, and let's work it together. So when you come down to this table, 220.88, and again, if you're out in the field driving, just listen. And when you get somewhere, take a break, crack your code book open, and go to 220.88 and look at the table. On the table, you'll see 3 columns. The left column is your total connected load, which is what the engineer or the exam gave you. It said 600 VA, okay, 600 kVA, okay? That's your total connected load. They just gave it to you. They've already done the work for you. Now, in the middle column, it says all electric restaurant. That's what we have. In the right, it says not all electric restaurant. So that means you might have, for example, some gas, okay? You might have some gas appliances and whatnot. So in our case, most of the time, the questions that I'm aware of on the electrical exams deal with an all-electric restaurant, okay? Now, it's not going to matter for you on the exam because whether they say it's all electric or not, they're still going to give you the total connected load. You just choose which one. They have to tell you whether it's an all electric or if it's not all electric. And the only way that you'd be able to tell is if they gave you a list of certain things and they ended up saying in there that it was a gas range or a gas this or what, then you should look at it and go, well, crap, it's not an all electric restaurant. And that's okay. They're still use the VA that they gave you, and you just choose which column to use. Now, in my experience, most of the time, the questions are based around an all-electric restaurant. But just be ready to, based on what they give you, they may give you a sentence that says all-electric restaurant with gas cooking or whatever. Then they're not trying to trick you. They're just making you think, well, wait a minute, it isn't an all-electric. And that's why you have the other column. And you apply the code the same way I'm going to do it here. But I just want you to be aware of that so you don't get tripped up by anything. All right, so in our case, it's an all-electric restaurant. So we're going to be using the total connected load column, and we're going to be using the center column, which is all-electric restaurant. All right, so now we had 600 kVA. So on the left, you'll notice that it goes 0 to 200, then it goes 201 to 325, and remember, that is kVA. So that is 0 to 200,000 VA. And then it's 201,000 to 325,000. And then you have 326,000 to 800,000. And then you got over 800,000. Okay, you see where we're doing all this? Okay, so now the first thing we're going to know is which one are we in? We're in the one that's 326 to 800, right? Because the engineer gave us, or the exam gave us 600 kVA. Perfect. So now we go to the right and we go to the center column. Now, what does it say? It says 50%. Now, the first thing that people do mistakenly is they take that 600 kVA and they drop it to 300. They think that's what this means. That is not what this means. Notice the order of working out an equation. You do the parentheses and you pay attention to the parentheses first. And here's what it says. It says amount that's over 325, and that is what the 50% is applied to. All right? So if we have 600, we have to take away 325. Okay? So the amount over 325. So I'm going to have 600, okay? And I'm going to take away 325. That gives me 275 kVA. Okay, so now what it says is take that amount at 50%. So I'm going to take that 275 and I'm going to multiply that by 0.50. And that gives me 135.5. And if you question your math, just do that times 2, and you'll see that takes you back to 275. Okay. So now that I have 135.5, then I'm going to actually finish the equation. It says plus 172.5. So I'm going to take that 135.5 plus 172.5. And that's going to be 308 kVA. That is now my calculated kVA. And I use that now to multiply that by whether it's single phase or 3-phase in order to find out what my conductors need to be. Okay. But this is the kind of question that you'll get on an exam, and you need to make sure you understand how to do this. Okay. For example, if this was single phase, then it would be 308. All right. And so me at this point, I like to actually go and make it all the way 308,000. And then I divide that by 240. And that is 1,283.3. And that is my amp rating. So I'm going to be 1,283. And then, of course, for me, I need to parallel that out so that I can see how many sets I need to be in order to be able to cover that 1,283. Okay. Now, if this was 3-phase, then you got to remember that it's the square root of 3 is 1.732. So I'm going to be taking what? I'm going to be taking that 308,000. Well, first of all, let's go in and get our value for the square that we're going to use in here. So it would be 208 times 1.732, and that would be 360.256. So we're going to make this 360.26. And now we're going to take that 308,000 divided by 360.26, and that's going to be 854.938, which is going to translate this into 855. So we have 855 amps, considerably less than if it was single phase, which was 1,200. So again, inherently, you see there are benefits in this case to the 3-phase. So I'm going to still do the same thing. And then at that point, I'm going to have to determine how many sets I need. In this case, the other one I might have needed 4. In this one, I might only need 3 or maybe even 2, depending. But that all depends, again, on what you're dealing with, whether it's 3-phase or single phase. And they have to give you that in the question, by the way. Okay, it's not something that you have to just, God, I wonder what it is. They're going to give you this information. So this is the kind of question that you'll see, for example, on a Texas exam. And you just need to be able to understand how this works. And I think the more important part is how the column works. Remember, in the center column, when it's all electric, it's telling you that the 50% is applied to the amount that's over 325. Okay? And then you add the 172.5 to that to get your total calculated load, okay? And that is no different if it's not an all-electric range. Same kind of concept. It's just the percentage values change, okay? So hopefully that's made it a little easier maybe. I know it's a podcast, so it's kind of difficult. But if you pause it, you follow along, and I sometimes take a lot of pride in making sure that I'm painting a mental picture. But sometimes, I can struggle with that because, if you understood it, let us know. Always, it's great to get your comments, thumbs up, share it with other people, share it with people that you work with. We have over 1,000 episodes of podcasts available on all your popular listening platforms. All you got to do is search for Master the NEC. And they're available on all those platforms. Or you can get our mobile app and you can get access to them directly from our mobile app. It's free. Just go to fasttracksystem.com, or you can go to necchat.com and download it from there as well. All right. So hopefully I explained that to you. You got a little better understanding of it and I didn't confuse you. But if you do have any confusion, you know what you can do. Just go to paulabernathy.com. Send me your question. Be very detailed about what you don't understand. Let me know what code cycle you're under, and be very detailed. in your question because it's hard for me to answer vague questions. So please be as detailed as possible. Till next time, folks, stay safe. God bless.